Okay, let's talk about a somewhat completely different subject of a manufacturing cycle efficiency. We have this chapter in decentralized organizations, so we're going to cover something that's a little bit different than we've covered before. Not talking about cost, volume, profit. We're talking about manufacturing efficiency. So what we're going to look at here, and there's a really good chart that talks about delivery performance measures, and it talks about how fast we get things through the production line. So we have order received, production started, and goods shipped. The distance between order received and production started is called wait time. That's the time that we simply are waiting for the production to begin. So they've ordered something, but it hasn't actually started in production line before yet. The production started has four components. This is the throughput time. The throughput time is process time, inspection time, move time, and queue time. And queue time is it's just sitting there in a line waiting to be used. And so queue time is wasted, as is move time and inspection time. Where we really value add is the process itself, where we're converting one thing into another. So there's two times here. The throughput time is the production to goods shipped, and then underneath that is the delivery cycle time, which is when we get the order to when we ship the goods. The process time is the only value added time. That's the time that we're really making our money. So if we look at that in terms of manufacturing cycle efficiency, the process time is the value added time divided by the manufacturing cycle time. So the process time through the manufacturing cycle time gives us our manufacturing cycle efficiency, and obviously we want to be as efficient as possible because that's going to improve our profitability. So let's answer some questions on this. The TQM team at Narton Corp has recorded the following average times: 3 days for wait, 0.4 days for inspection, 0.2 days for process, half a day for move, and 9.3 days sitting there in line, which doesn't sound so good to me. So what is the throughput time? The throughput time being all the time that excludes wait. Well, if we look at our answer, you'll see that the process, inspection, move, queue, if we add all that up, it's 10.4 days. Really all we've done is ignore the wait time of the overall delivery cycle time. We just eliminate the wait time and we find our throughput time. So that was pretty simple. The next question is, what is the manufacturing cycle efficiency? So if we think of the manufacturing cycle efficiency as our value added time, which is only our process time, and then we divide it by our throughput time, you'll see that the value added time divided by the throughput time gives you 0.2 days divided by 10.4 days, which is 1.9%. So 1.9% of the time we're actually doing something that makes us money. The other 98.1% of the time we are just sitting around. And so that is not the number we would prefer, obviously. And so we get into just-in-time manufacturing and shrinking our time frames down to just having our equipment there right when we need it and so on. So when you think of manufacturing cycle efficiency, obviously you want it as close to 1 as possible. We're nowhere close to 1 at 1%. The next question is, what is the delivery cycle time? Well, this one's quite simple. The delivery cycle time is the overall time. You simply add the wait time. In this case, it was 3 days, 3 days, 3 days of wait, and the 10.4 days of the throughput time for a total of 13.4 days for the throughput time. So that's quite simple. Once you have that chart, these questions are very easy to answer. You would be thinking about this as a production manager or somebody who's working in a production facility, because you want to narrow those times down as best you can so you don't have inventory sitting around doing nothing. And while you're processing a material, you want to be value adding as fast as you can. We've posted some videos, and of course you've seen some by various manufacturing processes. The Tesla video is particularly useful in thinking about how much time things are just sitting around and how much time things are actually moving and being value added. There's a lot of value added time in that Tesla video, and there's not much time moving and queuing and things like that. So if you apply that Tesla video to these numbers, you'll go, oh yeah, Tesla's doing better at keeping things moving along and adding a lot of process time, not a lot of queue time, not a lot of moving around time. The assembly line seems pretty darn efficient to me. So that concludes chapter 11 on decentralized organizations. Pretty simple chapter, pretty easy stuff. Shouldn't be any problem for you at all. And let's move on to the next chapter.